In this video, my aim is to give you the basic understanding of the terms virtual and real images. I am sure you will enjoy it. What you seen on your screen is a mirror. It has this plain and smooth reflecting surface on one side. It is called a plane mirror because its reflecting surface is flat. What other types of mirrors have you seen? Have you seen this type of mirror? Well, you must have seen it on the stand of your bathroom or maybe hung up there on a wall. This is not a plain mirror. Try to move your hand over the surface and you will notice it. This is called spherical mirror or more precisely spherical concave mirror. It is curved inwards. It is kept there as we use it mostly when we are shaving. Now, the obvious question that must we see an image of ourselves in the plane mirror. Nothing surprising there. Why are we able to see our image? Yes, it's due to the reflection of light. In fact, it is due to multiple reflections of light rays. How? The light rays from the source are first incident on our body. They bounce off from our body and fall on the surface of the mirror and again gets reflected from there. This reflector light then reaches our eyes and we see our image. So, what does this tell us? Yes, this tells us that a light ray can get reflected multiple times. The same thing happens for every other non-luminous object as well. If you remember, my initial goal was to explain what virtual and real images are. Let me ask you a question. This image that you see here, is it a real image or a virtual one? Yes, this image is a virtual image. In order to explain what a virtual image is, let's first simplify this image. Let's represent this boy with an arrow pointing up. And here is our plane mirror. You can assume the top of the arrow to be the top of the head of a boy. Now, where is the image of the boy formed? When we see the image in the mirror, it seems to us that the image is formed somewhere behind the mirror. But there is nothing behind the mirror, right? For us, the light rays seem to come from the location present behind the mirror. For instance, consider a few light rays emerging from the top of the arrow. All these rays are incident on the mirror and gets reflected back. Yes, all the reflector rays will follow the laws of reflection of light. You see that all the reflector rays are moving away from each other. These reflector rays diverging, but we know that the image is formed somewhere behind the mirror. So let me extend these reflector rays backwards and see what happens. We see that they meet at this point behind the mirror. And to us, this is where the top of the image appears to be. When we look at this point, it appears to us that all the light rays are diverging from this point. But in reality, there are no light rays behind the mirror. This being a smooth and shiny surface reflects most of the light back and almost no light reaches behind. But yet we have the perception that the light rays are coming from the point behind. So we just consider the top of the arrow here. We can do something similar for the remaining points on the object to get the complete image. So we say that the image formed here is virtual, or in other words, not real. You can think of a virtual image as an image which appears to be formed in a position somewhere behind the mirror. But in reality, it isn't there. A virtual image is formed when the light rays diverge after reflection from the mirror. Every plane mirror forms a virtual image. This is the first characteristic of the images formed by plane mirrors. Images formed by plane mirrors are virtual and not real. So what is the real image then? And how are they formed? Let's replace this plane mirror with a spherical concave mirror. Why? It's because real images can be formed by concave mirrors. Let's consider the light rays from the same point of the object incident on the mirror. We see that after reflection, each ray is traveling in a certain direction. Note that there as well, each ray obeys the laws of reflection. What difference did you notice here compared to the plane mirror reflection? In the previous case, all the reflector rays were diverging. Yes, here all the reflector rays after reflection are intersecting each other at this point, or we can say that they are converging at this point. And the image of top of the arrow is formed at this point, and we can do something similar for the remaining points of the object too. We get this image. This is called a real image. It is the image formed when light rays converge after reflection from the surface. One important thing we need to know is that real images are always inverted. Yes, concave mirrors are always inverted images forms. We will learn more about this in the future videos. The image is formed on the same side of the mirror as the object is. So real images are always formed on the same side as that of the object. And light rays do reach this position. When we look at the real image formed by a concave mirror, it is also seems to us that light rays are diverging. But here the rays actually are diverging from a point in front of a mirror. So whereas in the case of plane mirror, it appears to us that the light rays were diverging from the point behind the mirror. So did you understand the difference between virtual image and a real image. When we look at a virtual image, it appears to us that light rays are diverging from a point somewhere behind the mirror. But in reality, they are not, as no light reaches behind the mirror. It is also only our perception. And in the case of a real image, the light rays are actually diverging from the point present on the same side of the mirror.